Lab Guy here. Today I'm going to give you a quick update on the progress of the NBTV DissectorCam. It's in progress. The first circuitry has been wired onto a proto board, and that is the primary sync generator. There will be 3 phases predominantly to the construction of the circuits, and that will be starting with the master timing generator, which is exactly the same circuit as used in the 10-4 Eleanor video signal generator. It's essentially a crystal oscillator, a binary divider chain, a memory chip, and an output latch. This forms a state machine which generates all of our timing pulses, and the reset of the 3 counter chips, the binary counters, are tied to the lowest order bit in the data output of the memory in such a way that when the count reaches the final count address for the given clock frequency, it resets the counters, and the state machine continuously loops, producing a continuous repetitive pattern. It's a glorious way to do it. Much simpler than using combinatorial logic, because you can use that same circuit over and over in designs, as I have. The original incarnation of this circuit was in the PhiloCam, which was running at 267 lines at 15 frames a second. It's now running at 32 lines at 12.5 frames a second, and the hardware is identical. The timing patterns are produced using your favorite programming language. I believe today most people would use Python to achieve this. I am using extremely archaic QuickBasic, or a clone of QuickBasic that was produced recently. And I'm doing this because I'm building an archaic camera. I may as well use archaic software. If I could do this on punched cards, we'd sure be having a lot more fun than we are. I don't know if it's legal to have more fun than this. So the testing of the camera tube was also performed using my 2 audio function generators to drive the deflection yoke and to attempt to see the video on the oscilloscope. The video output from the dissector tube when viewing a nicely lit object is actually in the range of around 10 millivolts. That's 10,000ths of a volt, or about 100th of a volt, I suppose. And so the input to the oscilloscope's z-axis, which is the brightness control for the CRT, is designed actually for logic probing, and is designed to accept a 5-volt pulse to drive it from completely off to completely on. So 100th of a volt does not register in the CRT. It's present, but there's so little contrast you can't see it. And so I was having to use an immense amount of light. I could just barely see that something was there. If I shined the light, in this case was an LED flashlight, directly into the lens of the camera, it would then output up to a 10-volt signal. But that's considered photomultiplier tube abuse to do that. But it proves that the camera tube is producing output. So the construction order of circuits is the sync generator, followed by the scanning drivers for the deflection yoke, and finally the video amplifier, which will probably require the most development. I'm going to attempt to build the amplifier in such a way that it will have feedback circuit like we saw in the Craig 6104 camera, where they take a sample of the output video and rectify it and use it as a control voltage. So the output of the rectifier is a DC voltage proportional to the average level of the image. So let's say we have an image where 50% of the signal is black and 50% is white, and my control voltage is a range of 0 to 1 volt. Then in that case we should have a half a volt of control voltage. This is fed back to the input stage of the amplifier to literally turn the gain knob up and down. So in the first iteration of the circuit, I intend to put a manual gain knob so that we can light the subject matter with varying amounts of light and adjust the knob to get viewable images. And I'm going to attempt to create a calibration table from that where the numbers are written down so we can see if the response requirement is linear or in some form of a logarithmic control curve, so that I can intelligently design the control circuit to my best abilities. I'm kind of a boilerplate guy. I know how to hammer rivets where the real sophisticated engineer knows how to weld. So in both cases, the construction can be accomplished. One is much more elegant and reliable than the other. However, let's do it the old-fashioned way. Like I said, I want to do this in a Victorian style, using old software, old hardware, and achieve modern results. So that's my report for you today. We're still gaining lots of subscribers. Thank you for signing up. You guys rock. Greetings to all of my current subscribers. You guys keep it going. I really appreciate it. And stay tuned to this channel for more exciting projects. There's some more TV cameras in the pipeline that I will be experimenting with to make up for the failure of the Craig 6104, which technically wasn't a failure per se. We learned a lot from that. And I'll just keep dishing it out to you as I can. I promise. So until next time, this is Lab Guy, out.